Welcome to the 12th video in the Metric Math Water and Wastewater YouTube series. This video will focus on how to solve water and wastewater formulas by moving and isolating the variables. When dealing with math, you have to go back to some of the lessons and rules that were covered way back when in your long-forgotten high school days. Now, when solving for formulas, there's a couple of absolutely basic fundamental rules that you have to abide by. Whenever there's an equal sign, you want to try and have the numbers with their units all move to one side of the equal sign, and the unknown variable, the answer that you're looking for, the x, that's on the other side. Once that has been completed, the problem has been solved. Now, how do you move stuff across the equal sign? How do you move it from the right side of the equal sign to the other? Well, you have to do what's called the opposite arithmetic function. Now, if something is being added to something else, and you want to move it to the other side of the equal sign, the opposite of addition is subtraction. The opposite of multiplication is to divide. The opposite of squaring, like 5 times 5 is 25 squared. The opposite of squaring is the square root. There's many other arithmetic functions that are possible, but we're not going to look at those. We're just going to look at these first three. Now, an example of this. Now, by looking at the right hand, we know just by quick reflex that x is going to be 6. Some number times 5 equals 30. But if we didn't know that, and we had to go through the basic math of it, notice the x and the 5 are being multiplied together to get 30. So in order to move the 5 to the right side where all the numbers are, and leave the x, the unknown, by itself, x and 5 are being multiplied together, and the opposite of multiplication is division. So you divide both sides. As long as you do the same thing on both sides, you're okay. So divide both sides by 5. 5 divided by 5 cancels out to be 1. So there is an x by itself now on one side, and 30 divided by 5 is 6 on the other side. Now that problem has been solved. X is 6. So that's a really, really simple math problem that we can understand fairly well. Now let's take that to a little bit higher level. When we are dealing with water and wastewater formulas, at the base level, it's really easy when the unknown is already by itself and the known values are on the other side. For example, in this question, it's got the flow rate is 0.42 cubic meters per second. The area is 0.35 meters squared. And then we're supposed to find the velocity of the fluid in meters per second. Now, this would be really nice if flow rate was the unknown and the area and the velocity were given. But in this case, that's not happening. In this case, the velocity is the unknown. The velocity is the meters per second. So how do you move that 0.35 over to the left-hand side? Well, notice they are being multiplied together. Opposite of multiplication is division. So if you divide both sides by 0.35 meters squared, notice on the right side that cancels out. It's divided by itself, so that's 1. On the left side, that's 0.42 meters cubed per second divided by 0.35 meters squared. And notice the unit that you get is meters per second, and that is the correct unit for velocity. So we have got a very high confidence that this has been done correct. Answer is 1.2. Now, for people that have a good math background, plugging these numbers into this formula is relatively simple, and then moving it from one side of the equal sign to the other is also relatively simple. But those people that haven't done a lot of math recently, they make some really, really common errors. Now, in this case, the most common error is when you go back to the beginning and they look at this formula and they plug the numbers in, and they see that velocity and they move the 0.35 to the other side, the most common mistake is that they will multiply 0.42 times 0.35, and they obviously get a wrong answer. Now, by looking at the units for that, meters cubed per second multiplied by meters squared would get meters to the 5th per second. But in a lot of cases, they don't even put the units in anyway, so they wouldn't even pick up that there has been a mistake made. What we're going to be looking at here is an alternate way of setting up and solving that kind of dummies stuff down a little bit, but it works. Now let's take a look at an alternate method of setting up. Now think of a circle, and notice the circle is divided in half, top and bottom, and the bottom is divided in half again. Now think of that line going across the horizontal line. Think of that as a dividing line. So any number above that would be divided by the bottom numbers. 10 over 5 would be divided, 10 divided by 5 gives you 2. So that's what that circle represents. If we take a known little formula, 6 equals 2 times 3, whatever is by itself, the 6, that goes on the top. That's going to be the answer. And the ones in the bottom, the variables, they go on either side on the bottom. It doesn't matter which side they go to, they just go in the bottom. And you'll notice that the bottom 2 and the 3, they are multiplied together if they're side by side. 6 is on top of 3, and remember there's that horizontal line, that dividing line. So 6 divided by 3 would give an unknown answer that would be 2. Likewise, 6 is above 2, so 6 divided by 2 would give the answer of 3. Now this seems a little goofy, but let's apply that into a similar question that we've already looked at. Flow rate equals area times velocity. We know that formula is correct. So we put the answer, the one by itself, we put that on the top. And the two variables, the one that can change, we put those in the bottom. So one goes on one side, the area, and the other variable goes on the other side. That formula means that flow rate is equal to, and the 2 on the bottom are side by each, area and velocity are side by each, so you multiply them, area multiplied by velocity. Or, if you look at the bottom right-hand corner, velocity would be equal to the top one in the pie, flow rate, and notice how it is above that horizontal line, that dividing line. Velocity in the bottom right-hand corner would be equal to flow rate divided by area, which is correct. Or area on the bottom left-hand corner would be equal to flow rate divided by velocity. Now that's the theory behind it. It's a lot easier to set up, and it's much more consistent in terms of enforcing. So let's apply that same question that we had earlier. Let's apply it into this pie. So if flow rate is 0.42 meters cubed per second and the area is 0.35 meters squared, find the velocity. So again, we put the answer on the top. The flow rate is what the answer is supposed to be. And then we put in the area. Well, we know that one, 0.35 meters squared, and we don't know what the velocity is. So now when we set up the math solution, we don't really have to worry too much about whether we should multiply or whether we should divide or whatever. We just do what the picture says. Velocity is on the bottom right-hand corner. That's going to be equal to the top number, flow rate, divided by the one that's underneath it, area, or 0.42 cubic meters per second divided by 0.35 meters squared. So that's the easy setup. It makes much less probability of making a mistake when you're setting stuff up. And the answer is the same, 1.2 meters per second. Well, if that works for flow rate and area and velocity, let's take a look at some other examples. If you have watts equals volts times amps, put the watts on the top, put the volts on one bottom corner, put the amps in the other bottom corner, then all three of the possible manipulations of that formula come up really quick. Well, obviously watts is equal to the bottom two multiplied together, volts times amps. Or bottom right-hand corner amps is going to be equal to watts on top of volts, or watts divided by volts. Likewise, bottom left-hand corner volts is going to be equal to watts is on top of amps. And so there you can set it up very quickly. Another example, let's do a simple one like area, length, and width. So area would go on top, length is in one corner, width is in the other corner. Now again, area equals length times width. Well, that's pretty easy, but what happens if you have to solve for width? If width is the unknown, well then area is above length in the diagram, so area would be divided by length. Or bottom left-hand corner, if length is the unknown, then area is above the line of width, and so it would be area divided by width. Another formula, just a few more here for examples, just so that you get the hang of it. Detention time is a known formula. Detention time equals volume times flow rate. Detention time goes on top, volume in one corner, flow rate in the other. Now, if flow rate is the unknown, detention time is above volume, so it's a detention time divided by volume. Or if volume is the unknown, then it's detention time divided by flow rate. So again, those are really simple applications. Now, some of you may say, well, what happens if you have more than two variables as unknown? So what happens if you have three variables? How does this pie set up? Well, the known value always goes on the top half. The other values go on the bottom, length, width, height. If height is unknown and you're looking for it, then you would take the volume, and notice here you got to be careful. The volume divided by the length, and you get an answer, and then you take that answer and divide it by the width. Or if you take a look at the formula on the left, you will notice that you have the length times the width, get an answer. Then take the volume on the top divided by that answer, gives you the height. That's solving for one of the possibilities of that diagram. Another possibility is, let's say width is the unknown. Then you take the volume divided by the length, and that answer, whatever you get, you also have to divide by the height. Or take the length multiplied by the height, because they're side by each. Multiply those two together, get an answer. Volume divided by that answer. Hopefully this will give you a little bit better grasp on how to solve or manipulate for formulas. Please check out the other videos in this channel and put in some comments, and then pass this site on to any other water and wastewater students. Goodbye for now, and have a good day.